Hello, geometry scholars. Here we are. We're in chapter 7, and we're going over section 2, properties of parallelograms. Parallelograms are the majority of the polygons that we're going to study. They have some neat properties, and so we've got like 4 or 5 different theorems in this particular section. So take your time with it. We'll probably take 2 or 3 days just going over these. The core vocabulary is parallelogram, which I will define in a moment. Previously, we've talked about quadrilaterals, diagonals, interior angles, and segment bisector. So let's get started. A parallelogram is, so this is a definition, a quadrilateral with both pairs of opposite sides parallel, first of all. So in parallelogram PQRS, you'll see that PQ is parallel to RS with a single red triangle, and QR is parallel to PS with a double red triangles. This theorem below describes other properties of parallelograms, but that's the basic definition. That's what has to be met in order to call it a parallelogram. Now, Theorem 7.3 says, if a quadrilateral is a parallelogram, then its opposite sides are congruent. So if you know that they're parallel, then PQ is congruent to RS and QR is congruent to SP. Very handy. We also have a theorem that says the angles that are opposite are congruent. So Q is opposite S, and see how they're both the big angles? Those are congruent. And R and P are also congruent. You see that they're small angles. So that's the opposite angles theorem. There's a proof here about that opposite sides theorem. Because we have so much to cover, I'm not going to go over this proof right now, but you can see it. And if you want to, pause this video, read through it on your own. You have plenty of time to do that. So here we go. First example. Here's where we use the properties of the parallelograms to solve the problem.
Find the values of x and y. Solution. Because ABCD is a quadrilateral with both pairs of opposite sides parallel, ABCD is a parallelogram by the definition of a parallelogram. Use the parallelogram opposite sides theorem to find the value of x. By the parallelogram opposite sides theorem, opposite sides of a parallelogram are congruent. So, AB equals CD. Substitute x plus 4 for AB and 12 for CD. To solve for x, subtract 4 from each side of the equation. This gives you x equals 8. Now use the parallelogram opposite angles theorem to find the value of y. By the parallelogram opposite angles theorem, opposite angles of a parallelogram are congruent. So, angle A is congruent to angle C, or the measure of angle A equals the measure of angle C. So, y degrees equals 65 degrees, which means that y equals 65. So, in parallelogram ABCD, x equals 8 and y equals 65.
It's a lot of words, but that's what the concepts say. Here we go. Another, again, we'll do the monitoring progress in class. Now, here's some more properties. Okay. Remember back when we did parallel lines in chapter 3? The consecutive interior angles theorem, this is 3.4, states that if 2 parallel lines are cut by a transversal, then the pairs of consecutive interior angles, which here that's marked x and y, formed are supplementary. So if you add x and y together, you get 180 degrees. A pair of consecutive angles in a parallelogram is like a pair of consecutive interior angles between parallel lines. This similarity suggests the parallelogram consecutive angles theorem. So if you know that x plus y equals 180, right? This is what it says. Theorem 7.5. If a quadrilateral is a parallelogram, so if that basic definition is met, then its consecutive angles are supplementary. So if PQRS is a parallelogram, then x plus y equals 180. Now look, it's not just these two. It's this way also. Look, so angle Q plus angle R is 180. Angle R plus angle S is 180. Angle S plus angle Q is 180. And angle P plus angle Q is 180. So that's 4 different ways. Very powerful stuff. Okay, so now we're going to go on to the next one. Again, this is called a diagonals theorem. And the diagonals are right from the vertices across through the middle. This is another one that's unique to parallelograms. If a quadrilateral is a parallelogram, then its diagonals bisect each other. So that's really cool because then you know these things are equal. So if you have these two by diagonals, then you know that QM is equal to SM and PM is congruent to RM. And that's just something you got to know. Here we go. There's your another proof. Again, if you'd like to read the proof, stop the video and read through it. It uses angle, side angle, and alternate interior angles. But to make the video so it's not forever long, I'm going to keep going. Okay, using the properties of a parallelogram. This shows just like a little lamp. Here we go.
As shown, part of the extending arm of a desk lamp is a parallelogram. The angles of the parallelogram change as the lamp is raised and lowered. Find the measure of angle BCD when the measure of angle ADC equals 110 degrees. Solution. By the parallelogram consecutive angles theorem, the consecutive angle pairs in parallelogram ABCD are supplementary. So, the measure of angle ADC plus the measure of angle BCD equals 180 degrees. Because the measure of angle ADC equals 110 degrees, the measure of angle BCD equals 180 degrees minus 110 degrees, which equals 70 degrees.
Hopefully you can see that. If you know one, you can figure out the other one. Very handy. Okay, now, if we're going to use the properties of a parallelogram, then we should also be able to write a proof. So again, take this step by step. If you can't follow a step, go back and go over it, but listen to the proof.
Write a 2-column proof. Given that ABCD and GDEF are parallelograms, prove that angle B is congruent to angle F. You are given that ABCD and GDEF are parallelograms. By the parallelogram opposite angles theorem, if a quadrilateral is a parallelogram, then its opposite angles are congruent. So, angle CDA is congruent to angle B, and angle EDG is congruent to angle F. Next, notice that angle CDA and angle EDG are vertical angles. So, by the vertical angles congruence theorem, angle CDA is congruent to angle EDG. Then, by the transitive property of congruence, angle B is congruent to angle F.
Okay, hopefully you followed all that. Transitive property, right through the middle with vertical angles. Just have a little bit more to go through. These are monitoring problems. Now this part is the coordinate plane problems. We may or may not do them, but I am going to include them in the video.
Find the coordinates of the intersection of the diagonals of parallelogram LMNO with vertices L14, M74, N60, and O00. Solution. By the parallelogram diagonals theorem, the diagonals of a parallelogram bisect each other. So, the coordinates of the intersection are the midpoints of diagonals LN and OM. In this example, you can use either diagonal to find the coordinates of the intersection. Using diagonal OM helps simplify the calculation because one endpoint is 0, 0. Using the midpoint formula, the coordinates of the midpoint of segment OM are 7 plus 0 all divided by 2, 4 plus 0 all divided by 2, which equals 7/2, 2. So, the coordinates of the intersection of the diagonals are 7/2, 2. You can check your answer by graphing parallelogram LMNO and drawing the diagonals. The point of intersection appears to be correct.
A second example on the coordinate plane.
3 vertices of parallelogram WXYZ are W, -1, -3, X, -3, 2, and Z, 4, -4. Find the coordinates of vertex Y. Solution. Step 1. Graph the vertices W, -1, -3, X, -3, 2, and Z, 4, -4. Remember, when graphing a polygon in the coordinate plane, the name of the polygon gives the order of the vertices. So, for parallelogram WXYZ, connect the vertices W and X and the vertices Z and W. Step 2. Find the slope of segment WX. The slope of segment WX is equal to the quantity 2 minus -3 divided by the quantity -3 minus -1, which equals 5 divided by -2, or -5/2. Step 3. In parallelogram WXYZ, segment WX and segment YZ are parallel, which means they have the same slope. So, start at Z, 4, -4. Use the rise and run from step 2 to find vertex Y. A rise of 5 represents a change of 5 units up. A run of -2 represents a change of 2 units left. So, plot the point that it's 5 units up and 2 units left from Z, 4, -4. The point is 2, 1. Label it as vertex Y. Step 4. Find the slopes of segment XY and segment WZ to verify that they are parallel. The slope of segment XY is equal to the quantity 1 minus 2 divided by the quantity 2 minus -3, which equals -1 divided by 5, or -1/5. The slope of segment WZ is equal to the quantity -4 minus -3 divided by the quantity 4 minus -1, which equals -1 divided by 5, or -1/5. Because the slopes are the same, segment XY and segment WZ are parallel. So, the coordinates of vertex Y are 2, 1.
Plus, you can see if you did graph it, you'd see that it makes a parallelogram. Okay, so I believe that concludes the section lesson 7.2, and you can now go ahead and do your assignment in Big Ideas.